Okay. Thank you very much. My name is Devlin, and I'm happy to participate to Open Conf Prevent. I will be talking about vector database and the fundamentals around it. So, yeah, we can start now. So, slides. Um, um, yeah. So, just a quick introduction about me. I'm again Devlin Duldulao. I live and work here in Oslo, Norway for 5 years now, and I came from Manila, Philippines. And during the pandemic, couldn't go back to Manila, so I decided to write a book, and followed by two more. So that's I use my time during pandemic. So yeah, today, the rise of vector databases in AI and beyond. That's what I'm going to be discussing the whole time. And you know, why I'm here just to warn you that um, if you have an application and you want to use GPT models, etc., to be precise, it's very expensive if you're gonna tailor it specifically for your domain. If you want to to create this pre-training, um, and it will cost you like thousands of $100,000 or whatever. It's very expensive, and you can verify the message here in OpenAI. Like as you can see here on this URL, that it the pricing starts at $2 million to $3 million. It's very expensive to do pre-training, but there's a workaround, right? And that's why I'm here. Okay, so agenda. What is a vector? So we're going to talk about that. What is an embedding, and what is an embedding model? So what else? What is a vector database? What is RAG? I'm gonna do some demos. Also talk about hybrid systems in re-ranking and LLM applications if we have additional time. So it's a big topic, but I will going to give you the fundamentals, which is very important. So let's define first keyword search and versus semantic search. So keyword search, this method retrieves documents that contain exact matches or close variations of the terms in the query, while semantic search, this method retrieves documents that are conceptually similar to the query, even if they don't contain the exact terms. It relies on the semantic understanding of the content, similarity. um, I can do a quick demo right now, actually. uh, so I would maybe exit this, and then um, so I have a website here, where you can search for medicines. So let's try to search, let's say, eye pain, right? And we're going to check the correctness of the results. So I searched for eye pain, and it's giving me antiseptic cream, which is like an antibiotic, and a fever sheet, or headache, what, olive oil, eardrops. Well, if I'm the user, this doesn't help me, right? Because I'm not getting the right thing that I'm looking. What about in this other? This is just a sample way of how you can use semantic search in let's say in the pharmacy, but this is not a real pharmacy online store. So going to search here also eye pain. Oops. Um, okay, so vision, ocular, eye bright. So as you can see, I think this is way better than the previous one because the eye itself, the word eye, is similar to the word vision. As you can see here, ocular, which is means eyes also, and eye bright. So these two websites, these are the way you can compare keyword search base versus semantic. The other one is semantic. This is a keyword which doesn't return you the like similar results. It's just looking for the exact word of key pain, which is like it's looking for the exact words. It doesn't help you right much. That's why the other one will say that it's better because you have the results here. So this is just showing you the difference between a website that uses a keyword based search results, and then the other one semantic. This one uses semantic based search results. And in uh, semantic search, you can also use it in other stuff like recommendation system, like here in foods. When you start liking something, it's gonna start giving you results like similar to what you like, right? So this is just an introduction of keyword search base versus semantic search base. Now let's go back to the slides just to go back to the discussion. So now we have a basic. Now, what is a vector? A vector is a mathematical representation of stuff, or any like any could be like structured data or unstructured. So it's just an array of numbers. In mathematics, a vector is a quantity that has both magnitude and direction. It looks simple. You can hard code this in your IDE or using any programming language, right? What about embeddings? Because this is a specific type of vector representation. Normally, you'll encounter this in machine learning models, where dimensional data is mapped to vectors of significantly lower dimensions. If this is hard to grasp, um, I can just like show you like things that you might be like already familiar with. So I have here Lego. This is just like low dimensional space, three attributes of descriptions: red, small, then with six studs, right? And then high dimensional space, one, it's like a one blue piece of blank to the left, something like that, and then hundreds of thousands of this combined together. Just think that it is an array of numbers with meanings. The idea is to capture the semantic meaning of the data in a dense vector form where similar items are placed close together in a vector space. So the process is that you need an embedding model. This can be open source like EFI based v2, or closed source like text embedding ADA 002 from OpenAI. As you can see here, these are unstructured data. Then send it to the embedding model to process it and generate embeddings from it. Now we have embeddings. We need the data that the embeddings represent. A relational database is built to store structured data in columns and rows. We are not going to use this for saving the embeddings. Neither a NoSQL database Document database is a NoSQL database that focuses on storing, retrieving, and managing document-oriented information. What we need is a vector database. It is a specialized database where you can store many vectors alongside, its structured and unstructured data, and then retrieve them when needed. And here's a better way of looking at this. While storing the embeddings will be, grouped depending on how closely the words are related. Your query, for example, a desktop, might bring a MacBook and laptop because they are all personal computers or gadgets. And the thyme, rosemary, and oregano are located in the herbs area because these are herbs. This is like GPS. The embeddings are like latitude and longitude coordinates, but the array have hundreds of elements inside of it. This is vector database, and there are several things that you must know to have a performant database. Vector indexing. This involves organizing and structuring high dimensional data, typically vectors, to facilitate efficient querying. It's about how the data is stored and accessed. And you have these different algorithms, KD trees, ball trees, hashing. There's so many algorithms here. I'm going to discuss this further later, or give you the reason why. Search algorithms, are the techniques to retrieve the most relevant vectors from the database in response to a query. It's about how the data is queried and retrieved. And we have here KNN is used when the data set is manageable and the accuracy of the result is paramount, while ANN is preferred when the data set is large. Let's talk about distance metrics. This is also important or part of the fundamentals in vector database. Distance metrics are used to determine the similarity or dissimilarity between data points, which are the vectors. And here are the standard distance metrics. You have this Euclidean distance. This is math. If you went to like you're in college or your math subjects, probably you encountered this. Euclidean distance is the ordinary straight line distance between 2 points in Euclidean space. For vectors, it's the square root of the sum of the squared differences between corresponding elements. This is good for image similarity. Now, cosine similarity measures the cosine of the angle between two vectors. It determines whether two vectors are pointing in roughly the same direction. This is good for text concepts. The dot product, also known as the scalar product, measures the product of the magnitudes of the two vectors and the cosine of the angle between them. Algebraically, it is the sum of the products of corresponding entries of the two sequences of numbers. This is good for both image similarity and text. You will see them in action later in the demo. So let's see who are the vector database vendors out there. This is gonna be quick because it's a lot. We have this Pinecone, simple, user-friendly, and provides cloud-native solution. BV8, supporting fast sub-millisecond search results and both keyword and vector-based search functionalities. You have Qdrunt, it's emerging as first choice vector search backend. Milvus is offering the unique advantage of a disk and implementation for efficiency on this vector indexing. Zealous is a commercial parent entity of Milvus and offers a fully managed cloud solution built on top of Milvus. Chroma enables rapid prototyping with its Python JavaScript interface and embedded architecture, offering an array of hosting options. You have LanceDB, innovates with serverless architecture and a novel columnar data format. Vespa, offering optimized hybrid search capabilities through a combination of keyword and custom vector search functionalities. Valve specializes in handling multimodal data through highly distributed architecture. These databases offer the advantage of integrating vector search functionalities into existing data stores. I would recommend trying all of them before deciding which one to choose, because each one of them has different developer experience, in my opinion. And then you can also use, for example, Relari will, can analyze your results using metrics like precision or recall and rank aware methods, allowing you to compare the performance of each configuration. And then you can experiment with different configurations for hybrid search. For example, you might test varying the ratio of the sparse to dense search results, or adjust how each component contributes to overall retrieval score. um Sparse to dense is the similarity, similarity search. The other one, the sparse, is more on the key based search approach. So why it is important to check on different databases? Because they're using different algorithms for indexing, for retrieval. And then um there's a trade-off that most of all of them are doing in providing you the efficiency. Because um, the way it works is they're trading correctness of the results versus um, like how fast the query will be. So most of the time, like if you want to go to the like 100% accurate or 99% accurate, it takes time for the database to see all the, what I mean. It's just physics. It's looking for the whole environment of the data in the vector database. The more data the vector database has, the more time it takes for it to search the whole thing and then look for the right results for the query. So there's a trade-off, and also, if you're working in a project, you also have to decide whether, or most of the time is the QA will decide if the result is enough already to pass the test, or not. So again, or also the latency. So latency versus accuracy. So it's a very interesting part of the development process in application. Yeah, you just have to read and just to know which one to go and choose. Now we are done with explaining what is vector database. Let's see how it can help AI applications. um, Large language models, are machine learning models trained to predict the next token word in a text sentence. um, so this is just, just basic things here, like what LLM is. uh, it's LLM, it doesn't have, it doesn't know the data that you're, let's say, you're asking it. It's not a database. It was trained to predict the next word in, for example, in English, that it will give you the correct next word based on how grammatically it is. So that's how large language models work. Like, for example, GPT. Um, it doesn't know the fact. It's just, again, it was trained to predict it. So I just to give you a real world experience that I just had. So I asked GPT about my visa process, let's say in Chile, because I am attending a conference. Then it turns out I need a tourist visa. The wrong thing that I did is I asked GPT, right? At first it says, no, you don't need as a Filipino. Turns out I need. So that's a big mistake. Never ask GPT, because again, it's not a database. It's just predicting what it can give you in a correct grammatical order. So since large language models have flaws, we need something to provide to the large language models to make it a bit more accurate. So this is where the vector database comes in. You can store huge amount of data with these embeddings, and then quickly search from the vector database to give you results, and then you're going to use this to send to the LLM to process it and talk to you. Because, well, actually, you don't need LLM. The thing is, you need LLM for the computer to talk to you like a human. That's what the LLM is doing. This GPT. You need someone to talk to. It's like you can talk to like a chatting, right? Otherwise, it's just like this huge response from the database, and then you read it by yourself. Again, large language have flaws, and vector database to the rescue to get all this large data and then put it in this highly compact vector embeddings. Or you don't need, you don't need vector database. You just use SQL or NoSQL database, but it's not for like huge unstructured and mixed unstructured and structured data. It's just for querying, takes time. And then vector database is like this, has this built-in search engine, right? With that can give you results with similarity, like synonyms, something like that. So let's go to the last demo before we end. I think um, I can give you something like this. This is before my last demo. As you can see here, it's really quick. Laser pointer, user send request, right? And then the back end will go to the embedding model just to see um, to 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 uh, uh, to create these embeddings. Even your prompts get converted into embeddings. As you can see here, you have this embedding model. And then after embedding the query of the user, it goes to this vector database for similarity search, because vector database can only do similarity search if what you're using is also an embedding, right? So it has to be converted into embedding before it can look, because it doesn't make sense if these are just plain text in English or even in Spanish language and then comparing it with vector, right? It has to be vector to vector. Then after that, you get the data from the vector database, and then you're going to use this inside a template, the data. Again, you can read this if you want, but it doesn't like human. That's why you need this OpenAI or Azure OpenAI or whatever, or other LLM providers. Send it there in a template with this, like, and then the response is like human. So this is just like a basic structure of uh, um, of RAG, right? Um, okay, so we still have time for a quick demo. Let's see here. Um, so RAG means retrieval augmented generation, by the way. Um, um, Sharing here. So um, this is Jupyter extension on VS Code. So this is just a simple representation of vector database, of how to use it. So you need um, for example, Qdrant database sentence transformers. This sentence transformers is the model for making embeddings, and then Qdrant client is the one that can save the embeddings for you, right? So I'm not gonna run this anymore because I ran it already. So you can see here we're using the models from sentence transformer in Qdrant, and then we're using a model type, all mini LM L6 V2, using this sentence transformer from Python library. It's an encoder, and then it's just basically it's going to encode all the things here. These are just a structured like books here, as you can see, data. So we're going to put it in documents there. because we're going to use it down here. And now we're going to use qdrant. I'm not going to run this because I deleted the API key, by the way. I'm just going to use a reference there, my books, collection name. And then I'm going to use create a collection name, my books, as you can see here. Models vector params. We need an encoder, the sentence transformer, get sentence embedding dimension, as you can see there, and then what type of distance model, say cosine, right? So now we have a collection ready. We're going to upload our data, which is the documents, to the collection. So this is where the documents going to be transformed first into embeddings using the encoder before it gets put to the reference. And now, let's say we have a query about meals. Let's say this is a user querying about movies about meals. Oh, sorry, it's not books. It's about movies. We have this query vector encoder. We have to encode first again this movies about meals, this query. And then we have hits here, limit, 5 results. We need this query vector, right? And then the collection name, which is my books. And then we're going to print or log the score so you can see the score. So it gives me this search, movies about meals, this data here, this response about food. So see, it's about food. I use meal, but it's giving me food and meal. So because they belong to, like, similar, right? And then you can see the score here. 0.4, 0.3, 0.2, 0.45, whatever. So which one to pick? It depends on the application. So if I were you, just ask the QA, someone who's testing it, if that's enough already. So you can set what score do you prefer here for the response. So it depends. There's no right and wrong here. It's just if the product owner accepts it. It's like, okay, this is good enough because this already helps our users or our customers. Okay, so that's the basic of vector database. I think I'm going to go back to running out of time. Yeah, there's so many techniques here. There's like re-ranking, also like ranking again the results using different things, like hybrid, using semantic and keyword together. Yeah, so and then LLM application architecture. So you have this data filtering also that you can use, prompt optimization tool, LLM cache, content classifier and filter, telemetry service, all along together in a architecture. So yeah, we have learned that, just going to summarize this, we have learned that embeddings are vectors with meanings, and you can use a vector database to save embeddings. We also know that indexing is a process in the vector database of organizing the embeddings or faster querying. Search algorithms are also algorithms for searching for results, and distance metrics are used to compare relevancy between two embeddings. We also have looked at different vector database vendors and limitations of LLMs, such as hallucinations and outdated knowledge. Like what happened to me, the GPT hallucinated the answer, give me an answer, and then I cannot go to Chile anymore because I don't have much time because I need to apply for visa. So don't do what I did. Okay, so lastly, we have learned about RAG, hybrid RAG and re-ranking for solving the limitations of LLMs. The repositories here, you can take a picture or just see it. and it's just in my GitHub, Webmaster Devlin, vector database presentation. You can search it there. Resources, there's so many because I'm just reading a lot. It's so very interesting. Here it is. You can take pictures also. I hope this presentation will help you get started with vector databases. So start building AI applications that bring value to your users. Until next time, happy coding. Peace out.